First off, what's the equation of our original line? Okay, so let's go off of that first. So what's the equation of our original line? Okay, that's your slope. So what's the actual equation? If we write it in, y equals, where does it cross the y-intercept? At 5. So then it's going to be a plus 5 on the back end. What's my slope? So now down 3 over 2, so negative 3 halves x. So if that's our original line, so the first thing we have to do, A was what? Do a parallel line through that point. So if we have to do a parallel line through 4, negative 2 that we have through this point that's given, how are we going to use that? Do you want to use slope-intercept? Do you want to use point-slope? What do you want to do? Which one? Point-slope? Okay, so if we go point-slope, remember that is y minus y1 equal to m times x minus x sub 1. So then if we're going to do parallel, okay, to start, we're going to go y minus, what's my y value? Negative 2 equals, what slope am I going to use? Negative 3 halves, right? Nothing changes if it's parallel. I'm just going to use that point or that slope again. And then x minus negative 4. So that's going to change to a plus. Same way over here on the left side. So I have y plus 2 equals negative 3 halves x. And then what's 3 halves? Negative 3 halves times a positive 4. Negative, what's 4 divided by 2? Negative 6, thank you. Now what? Subtract 2. So then my equation of my parallel line is going to be y equal to negative 3 halves x minus 8. Judging where, okay, granted you only have so much that you can see, but judging off of about where it's going to go, is it headed for negative 8? Yeah? Okay. Now, what's the only thing different that we're going to do for a perpendicular line, though? For the second part. Yeah. Yeah, opposite reciprocal of my slope. The negative 2 and the negative 4 are going to stay the same. The only thing that's going to be different is whenever we, as far as like our setup, is going to be the y minus negative 2. Nothing changes there. It's just going to be a positive 2/3 times x minus a negative 4. Okay, we just flip that slope and we change it from a negative to a positive. Okay. Now, in doing that, it's not going to be as nice and neat as it was with a parallel line. That's okay. So then I still have y plus 2. I'm going to have 2/3 x plus, leave it as a fraction. Okay, 2 times 4 is 8, so just leave it as 8 over 3. And then if I have to subtract 2, what is 2 written as with a denominator of 3? Well, 2 over 1, but it has to have a denominator of 3. So 6 over 3, right? So 6 over 3 is the same thing as negative 2 or minus 2. So my slope of my new line is of a perpendicular line is going to be 2/3 x plus 2/3. So it's going to hit basically somewhere close to about right there. So again, it's all, does that look pretty close to parallel? Yeah, or perpendicular rather? Yeah. Okay, so you're on the right track. Okay. Pretty short, sweet. Okay, and just writing equations of lines. And realistically, you're probably not going to use a whole lot of variation. Currently, we'll get to it more in depth later. But this is something that they will put on, like your ACT and your EOC and things of that nature. So that's kind of why we touch it. So whenever we talk about different types of variation, we have direct variation and we have inverse variation. Okay? Direct variation just has the form where it's two variables vary directly if y is equal to k times x. Okay? It's basically saying that you have two variables, your y and your x, and then k. K is just short for constant, is really all that means. Okay? It's that whole, whenever we talked about different equations, it's basically that hourly paying job. Okay? X would be like your hours that you work, and K would be your hourly pay. Okay? The reason why it's not like the y equals mx plus b where it's completely linear, it's going to be linear, but there's no y-intercept, because for most, if you think about like an hourly paying job, you don't automatically get paid an amount. Okay? You get paid per hour, and that's it. Okay? There's not like you get an extra $5 just to show up, or just because you work there. Right? It's just strictly like an hourly paying job. So K is a constant. Okay? It's just basically the line is always going to go through the origin. Okay? That is never going to be any different. So it's always going to have, if you would have to graph this, it would always go through the origin. Your y-intercept is always going to be at 0. Okay? Regardless of what we're dealing with or talking about. So it says the variables x and y vary directly. Write an equation that relates the variables. So when x is equal to 5 and y is equal to 7. So the first thing I want to do is I want to solve for k. I want to figure out what k is. So if I have y equal to k times x, what am I going to plug in for x and y? Like what number am I going to put in for x? And it's just going to be 7 equal to k times 5. Okay? What you're going to do is you're going to try to figure out what is my variable, what is k, what's my constant. Okay? So if I solve for k, so what's k going to be equal to? 7 over 5, right? So if my constant, it's really that simple. Don't overcomplicate this. So we're really just solving for k. Now, the added part is when we're going to plug that value into the general equation. So all we're going to do is we're going to take this y equal to k times x, and instead of it being y equals k times x, it's just going to be y equals 7/5 times x. Now, if at some point it asks you then to find, well, what's y when x is 10? Okay, so now that you know what k is, what am I going to do with the 10? Now, this isn't on your notes, but what would I do if it says, now find y when x is 10? What would I do with the 10? Plug it into the equation. So I just take 7/5 times 10. Whoop. And I would get my new y value. So all I would do is just take y equals 7/5 times 10. Well, that's 2. So what's y equal to? 14? Sorry, you can't see that. Don't overcomplicate it. It's not. Okay, direct variation, and then whenever we get into inverse variation, we'll get an inverse variation later. Okay, don't make it harder than it really is. So it says, do x and y vary directly? So basically, does it have a constant slope? Does it have the same change in y over the change in x? Yes, no? You don't know. Okay, why not?
Because 12, and then, okay, 12, and then 14, then 12, then 15.
So similar to what we've done before, right? These values, as we go up, it's the x value is going up by a constant rate of 3 each time, right? So they're not going to vary directly because I have 12 over 3, so my k would be 4 in this case, whereas with 14 over 3, my k is not going to be 4. Okay, 12 divided by 3 is not going to be 4. It will be at other places here, but it has to be the entire time. So 12 over 3 is 4, so on and so forth. So it changes from one to the other. What about on the second one? Yeah? No? Maybe? Yes? Okay. If as I go, all I have to do is just take the y and divide it by x. Okay, 0.3, 0.3. Starting to see a pattern. So yes, everything's good. Okay. You'll see a little bit of direct variation, not a whole lot. Okay, but this is really just so whenever you get into ACT and